The timeout here is our key ingredient for detecting lost packets, but how long should that timeout be? We could wait a very short time or a very long time, and it's not immediately obvious what is best. Now, if we happen to know how long it should take to get to the receiving side and for that receiving side to send back an acknowledgement, that corresponds to the round-trip time of a packet. And that would be useful as a kind of minimum timeout. If we don't hear something after that amount of time, then maybe things are just a little slow, or maybe it actually got lost. But if we pick our timeout time as too small, maybe exactly the round trip time is a little bit too small, for example, then we're going to end up sending too much data and we'll get too many acknowledgments and negative acknowledgments, and we'll create a lot of extra traffic. On the other hand, if we pick a timeout that's too large, then we're going to spend a lot of time waiting around, waiting to hear when the other side is not going to get a packet to try to tell us a message back. A good strategy is to take the average round trip time, apply some scale, some fudge factor on the order of 1.5 or 2 to say, okay, we haven't heard yet, but maybe we're just on the upper end of the round trip time. And then adapt based on the history that you see. So by taking the standard deviation of the round trip times that we've seen recently, then our choice of a timeout will adapt as the network gets very big and our timeouts start to get lower and lower. So as we will see, TCP uses this sort of calculation to decide on its timeouts. And it doesn't have to know the RTT in advance. It can infer the RTT and derive an average RTT based on how quickly it hears acknowledgments from the data that it sends.